Good.
You good? All right. My name is Wesley. I'll be your extreme scientist for today. And this is the Method to the Madness show. And this show is all about the scientific method. So the scientific method is something that scientists have been using for hundreds of years all over the world to perform their experiments. So today we're going to be focusing on 3 steps in the scientific method. Making observations, forming a hypothesis, and performing experiments. So making observations. You make observations all the time with your 5 senses. You guys name your 5 senses? Just yell them out. Sight, yep. Know the other ones?
What? Don't know.
Sight, hearing,
Touch,
smell, and taste, right? So we'll be using most of those to make observations today. Unfortunately, we won't be tasting anything. But you can use your other 4 senses to make observations. The next step is forming a hypothesis. Now, a hypothesis is basically just an educated guess. And are you always right when you make a guess? No, right? Sometimes you're right, sometimes you're wrong. And that's what the 3rd step is for, performing the experiments. So we come up with our hypothesis, and then we perform an experiment to see if our guess is right or not. So my first experiment involves these 2 balloons right here. What do you observe about these 2 balloons? Just shout them out.
What, Money?
Their color, yeah, they have 2 different colors. What else do you notice?
Gas inside?
The different strings, yeah. Different color string, different heights, right? And they're floating. That's a very good observation. So based on the fact that they're floating, what do you hypothesize? What do you think I filled inside these balloons?
Gas?
Gas? Well, yeah, helium gas. That's a good hypothesis. So one thing I know about helium, it does not combust. It does not ignite when a flame is put to it. So I'm going to perform an experiment to see if there's helium in my balloon by setting it on fire. Alright, so there's going to be a loud noise, so you might want to cover your ears. Give me a countdown. I'll pop the balloon in 3, 2, 1.
Wow.
What did you observe there? What happened to my balloon?
Explode.
It popped, but not only did it pop, it exploded, right? You saw a big cloud of fire. And the reason there was that big fireball is that was not helium gas, that was actually hydrogen gas. And hydrogen is very flammable, very combustible. So that's why when I put my ignition stick to it, it popped and made a big flame. So that's how we knew it is not helium. Alright, so what do you hypothesize will happen with this next balloon? Do you think it's the same thing's going to happen or something different?
Something different.
Something different? Alright, let's find out. It's going to be another loud noise. And 3, 2, 1. So what did you observe about that balloon? It changed color. It was green. Very good. That's because I added something a little extra into my balloon. So what color is the Statue of Liberty? Green. And do you know what the Statue of Liberty is made out of? Copper. Very good.
Wow.
That's because, and the reason that flame inside the balloon was green is I added a little bit of copper powder inside the balloon, and that's what changed it to be green. Alright, I'm going to make another experiment over here, and this one involves some iron spheres. So let me get some gloves on so I can be safe. Alright, so I have 2 iron spheres right here, and I can observe that they're about the same weight, they're about the same size. So what do you hypothesize, what do you think will happen if I put these 2 iron spheres together? You can just shout it out.
Make a noise.
Make a noise, yeah. Make a spark, maybe. Alright, let's see what happens. So what do you observe? A noise, yeah. That's because when I move the spheres around, that creates kinetic energy, or the energy of motion. And then, when these spheres hit together at a single point, that transfers to sound energy, and that's why we hear a noise. For this next experiment, I'm going to need a volunteer. Any volunteers? Alright, sure. Come up. Alright, you can come over here. What is your name? Monique? Is that right? Everyone say hi, Monique.
Hi.
And what do you say back to them? Hi. Okay, so I'm going to have you put on these safety glasses so we can practice dive safety. And I'm going to have you hold this paper right out like this, sideways spheres. And what do you guys hypothesize will happen? What do you think will happen if I hit these iron spheres together with the paper in the middle here? Hold it over here. Or just face this, change, rotate from here to here. Yeah, and then you can come back over here. Sorry, I'm making us move all around here. So what do you hypothesize will happen if I hit these balls together with the paper in the middle?
Quieter.
It'll be a quieter noise? You don't think it'll be a louder noise? Make no noise? Something completely different? Well, let's see what happens. Hold that paper right out there. And
Damn.
alright, so
Wow.
what do you observe?
Like a hole.
What do you see on the paper? Yeah, there are little holes in the paper now, right? And you smell anything? You smell the paper?
It's burned.
Smells a bit like it's burning, right? That's because when I move these iron spheres together, it made kinetic energy, and I hit them together with the paper in between, and all that energy went to a single point, made thermal energy, and that's why it burned those little holes in the paper. All right, everyone give her a round of applause. I can take the safety glasses back, and you can take that paper home with you and put it on the fridge and show all your friends. All right, so my next experiment, we're going to be making some more hypotheses here. I'm going to fill my jar. A little more than halfway, that should be good. So what do you think would happen if I tip this jar over right now? If the water would stay in the jar or go all over the floor? All over the floor, and I don't want that. I'll have to come mop it up later, and I don't want to do that. So what could I do to prevent the water from going all over the floor? Put a lid on it. That is a very good idea. Boom. Put a lid on it right there. So now, what do you think will happen if I flip it over? Will it stay in the jar or go all over the floor?
Stay in the jar.
Stay in the jar. Yep, that lid is keeping the water in the jar. But what is keeping the lid on the jar? My hand. Very good. So what do you think would happen if I removed my hand? What do you hypothesize would happen? It'll go on the floor? Anyone think it'll stay in the jar? Maybe? Alright, let's find out.
Wow.
Well, that lid stays on the jar. And that is because of air pressure. There's a little bit of air in the jar, and there's a lot of air all around us, and that air pressure is keeping the lid on the jar. So what do you hypothesize will happen if I take the lid off the jar? You think it'll stay in the jar or go all over the floor, make a huge mess, have to clean it up? What do you think?
Make a mess.
Make a huge mess? Alright, let's find out. Okay, well it made a small bit of water on the floor, but most of the water is staying in the jar. How's that possible? Well, I'll bring it around and I'll show you that there's a little wire mesh on my jar, and water is cohesive and adhesive. It likes to stick to itself and likes to stick to other things. So that creates surface tension on the surface of my jar here. And that is a very delicate surface tension because if there's any change in pressure, like if I tilt the jar, surface tension breaks and all the water comes out. Okay, so for this next part, we're going to be making observations again. We're going to be using our senses. So I'm going to put water in one of these cups. And I'm going to shuffle them around, and you're going to try and use your eyes to track which cup has the water in it. Does that sound good? All right. I'm going to start shuffling these cups around here. Think you still know which one has the water? All right. Does anyone think this cup has the water?
No.
No. Anyone think this cup has the water?
No.
No. Anyone think this cup has the water?
Yes. Huh?
Well, I will admit I cheated a little bit here, and I put something else in that cup. And I did it so well that I can't get it out. There we go. This is what my water looks like now. It's transformed into this jelly stuff. So, what I put in the bottom of my cup before you guys came here was this stuff. So what do you observe about this stuff? What color is it?
White.
It's white, and is it a solid, liquid, or gas? Solid, and it's not like a solid like these bleachers. It's a, what kind of form is it's a powder, right? It's a small, solid white powder. So what do you hypothesize? What do you think it is? Sugar? I hope it's sugar, then I can eat some. But it is sodium polyacrylate. That's a big word, hard to say. And it is a super absorbent polymer. So when I pour this water in here, in just a few seconds, all my water will gel up, and that's what keeps it in the beaker.
Oh.
So if you have a baby at home or anyone else who wears a diaper, that's in diapers because it's so absorbent, it can absorb up to 300 times its own weight. That is very cool stuff. All right, going on for my next experiment here, and we're going to be making more observations.
Wow. What
So
is
what do
it?
you observe about the stuff I just put in my beaker here? What's happening to it? What's happening? It's bubbling, right? And that's because it is boiling. So when we think of something's boiling, do we think it's hot or cold?
Hot.
Yeah, if you put a pot of water on the stove to make some spaghetti, that water is very hot. You would not want to touch it. But this is actually very cold. It is negative 320 degrees, and this is liquid nitrogen. That's what I just put in my beaker. So as you can see, it's rapidly boiling because it is 70 degrees in this room, give or take. So that's about a 400 degree difference. So that's why it is boiling. That's why we get the bubbles and we get that vapor. Okay, so I got some balloons here. How many of these balloons do you think I could fit in my container? Here, maybe 1, 2, maybe more? 2? Well, let's find out. So there's one balloon. And be listening if any of the balloons pop, because that doesn't count if any of them pop. And there's 2 balloons. Here's 3 balloons.
Wow.
4 balloons. I could do this all day. And 5 balloons. 6 balloons. It was a little big, but it still fit in there. And I don't have any more balloons, but if I did, I could probably fit even more in here. So these are what my balloons look like now. They're all shriveled up. So what happened is this liquid nitrogen is so cold that it took gaseous air, because air is a gas at room temperature, and
Look at those balloons, Bonnie.
into liquid air. And liquid is a lot more dense than gas. It takes up less space. So that's why all these balloons shrivel up. But when I take them back out and put them in our 70 degree air, that liquid air changes back into a gas and they reinflate. Last balloon in there. There it is. Oh yeah, it fell. That's okay. All right. So here I have this jug of water. Let's see what happens what do you hypothesize will happen when I put liquid nitrogen in this jug of water? Any guesses?
It'll freeze.
It'll freeze? Maybe. Anyone think it'll explode? I hope not, because I'm standing right next to it. All right, here we go. Put some liquid nitrogen in there, and it didn't explode, but I have some fog here. I have a cloud, so I can bring it around, and you guys can put your hands through it. It feels a little cold, but not too much. So to make a cloud, you need 3 things. You need moisture, water, particulates in the air, and a change in temperature or pressure. So we just made a big change in temperature, about 400 degrees, and that's what makes that vapor come out of the bottle. All right, so we've done a lot of making observations, forming hypotheses, and performing experiments. Next one, we're going to come over here. This is my biggest experiment so far. Uses all 3, and it's so big that I've dedicated its own table to it. Okay, so what do you observe is in my flask here? Water? Well, maybe it is a liquid, and it is clear. What else might it be? It's a clear liquid. Vinegar? I might have heard hydrogen peroxide. Those are all good guesses. And it is hydrogen peroxide. But it's not the stuff you might have at home. The stuff you might have at home is 3% concentration. and this is 35% concentration. So if I were to cut my finger and put this on it, it would give me a severe chemical burn, and that would not be good. So what do you guys think this stuff is?
A soap?
Food coloring?
Soap.
Soap? It is soap. So one thing about hydrogen peroxide is its chemical formula is H2O2. And as you all probably know, water is H2O. So there's an extra oxygen gas there. And that oxygen gas wants to leave. It wants to go somewhere else. So hydrogen peroxide is always breaking down into water and oxygen gas. That's why we put it in a dark colored bottle so there's no light that can enter it and accelerate that reaction. So that's why I'm going to use soap, because soap is very good at making bubbles, right? It's good at trapping oxygen gas. So I'm going to put the soap in there. So that's going to capture all the oxygen gas that is coming off my peroxide. Now all we have to do is wait 6 to 8 months and we'll see all that oxygen gas get trapped in the soap. Does that sound good? Wait here 6 to 8 months? No? You want to go home and eat dinner? Sleep in your own bed? Well, that's okay, I do too. So that's why I have this catalyst here. And a catalyst is anything that can make a reaction go faster. It could be heat or pressure or light. But this is a chemical, this is potassium iodide, and this will accelerate my reaction. So rather than taking 6 to 8 months, it will take 6 to 8 seconds, and then we can all go home, and it'll work better with our schedules. So that's very good. But before I do that, I'm going to add a little bit of food coloring, make it all nice and fun. Swirl that around there. All right, now I'll get my potassium iodide, and we'll put it in the peroxide and see what happens. Okay, can I have a countdown? 3, 2, 1. Pour that in there. And
Oh.
oh, that made that's capturing a lot of oxygen gas that's coming out of our reaction there. So what else do you see coming off of my reaction here?
Smoke.
Or heat, it's steam. That's because this is an exothermic reaction, which means it gives off heat. And that's heating the water. Remember, this reaction is making hydrogen peroxide go into water and oxygen gas. So it's heating the water, and that's why we get this steam. And our soap is doing very well at capturing all that oxygen gas that's going to be coming out of the flask for the next few minutes here. All right, those are all my demonstrations for you all. Thank you for coming. You've been a great audience. And feel free to ask me any questions afterwards, and enjoy the rest of your day.